Most new homes in the United States aren't built to last. They're built to close. Now, that doesn't mean they're unsafe, and it doesn't mean builders are trying to sabotage anyone. But if you look at them the way an engineer or auditor would, a different picture starts to appear. A modern house is usually assembled in less than a year. Crews move fast, inspections check minimum requirements, and once the keys change hands, the system moves on to the next lot. And that word minimum matters. Building codes are designed to set the floor the lowest acceptable level of safety and performance, not the ceiling of durability. So a home can pass every inspection, look beautiful during the walkthrough, and still contain small design compromises that only reveal themselves after a few seasons of real living. Maybe it's a water path hidden behind siding. Maybe it's an HVAC system that was never properly balanced. Maybe the drainage around the foundation was rushed before landscaping went in.
None of these problems show up on closing day, but they show up later, House, in comfort complaints, repair bills, and long weekend.
Spent trying to understand why a brand new house already feels like a maintenance project.
And once you understand the pattern behind those problems, you start seeing it everywhere. The production line problem. Let's zoom out for a moment. Because if these problems were random, the defects would look random too. But they don't. Once you step back and look at how new homes are actually built, a pattern starts to emerge. Start with the pace of construction. Recent housing data shows that the average new single-family home in the United States is completed in a little over 9 months from start to finish. That includes everything from framing and wiring to insulation, drywall, and final finishes. In other words, the modern home is built on a fairly tight production timeline. Crews move quickly, trades rotate in and out, and the project has to keep moving forward because delays ripple through the entire schedule. Then consider how many different hands are involved.
According to industry studies, the typical new home involves around 24 subcontractors.
Electricians, plumbers, framers, roofers, HVAC installers, insulation crews, drywall teams, flooring installers, siding contractors, landscapers, the list keeps going.
And most of the actual construction work is done by these subcontractors rather than by the builder directly.
Each of those trades is usually responsible for a very specific piece of the house. Their job is to complete their portion efficiently so the next crew can come in. But when a building system crosses the boundary between trades, like where a roof meets a wall or where ductwork passes through a sealed attic, that's where responsibility can become blurry.
Those transition points are also where many hidden defects begin.
Construction companies across the country have been reporting persistent labor shortages, which makes it harder to find experienced workers and often forces schedules to stay aggressive. When skilled labor is tight, the margin for careful detailing gets smaller. And while inspections do exist, they are designed to confirm that the house meets minimum code requirements, not to evaluate every long-term durability detail inside the structure. Put all of that together, fast timelines, many subcontractors, workforce strain, and minimum standard inspections. And you start to see why the same kinds of problems appear again and again in completely different neighborhoods.
And this is where the industry language starts doing a lot of heavy lifting. Especially one phrase you hear constantly in real estate: built to code.
Industry lie. It sounds reassuring, almost like a quality certification, but in reality it means something much narrower. Building codes are written to establish minimum requirements. The goal is to ensure that homes meet baseline standards for safety and basic performance: structure, fire protection, plumbing, electrical systems, things like that. Passing code means the house cleared the legal floor. It does not mean it was built with long-term durability, easy maintenance, or careful detailing in mind.
That distinction matters more than most buyers realize.
Because code compliance is about whether something is technically acceptable at the moment, it's inspected. It doesn't necessarily tell you how well that detail was executed or how that assembly will behave after 5 or 10 years of weather expansion and everyday use. You can build a wall that technically meets code but still allows small water paths over time. You can install HVAC equipment that satisfies the requirement for heating and cooling capacity, yet was never properly balanced once the system was finished. You can place plumbing shutoffs or service points in locations that technically pass inspection, but become extremely difficult to access later.
None of those choices violate the code, but they change the ownership experience.
And then there's the second phrase that often follows close behind: don't worry, it's under warranty. Warranties do exist and they serve a purpose. Most new homes come with a structure that covers workmanship for about a year, systems for a bit longer, and major structural components for several years after that. But a warranty is not the same thing as durability. It's simply a process for handling problems if they appear, which means the real question isn't whether a house passed inspection or carries a warranty. The real question is how the house was actually put together. The hidden engineering trade-offs. To answer that question, we stop looking at the brochure and we start looking at the assemblies. Because a house isn't really a single object. It's a machine made of layers, and every exterior wall and roof is supposed to manage 3 basic jobs at the same time. First, it has to control water. Rain, melting snow, and wind-driven moisture are constantly trying to get inside the structure. Second, it has to control air. Air leaks carry moisture waste energy and create pressure imbalances inside the home. Third, it has to control heat, which is the job of insulation and thermal continuity. When those 3 layers, water, air, and thermal, are continuous and properly connected, a building tends to perform quietly for decades. But when those layers are interrupted, misaligned, or installed loosely, the problems usually start small and then grow slowly over time. And here's the part most buyers never see. The weak points in a house are almost never in the middle of a wall. They're at the transitions, where the roof meets a wall, where a window interrupts the siding, where ductwork or plumbing passes through the structure. Every one of those locations requires multiple materials from different trades to line up correctly. Flashing membranes, sealants, framing, insulation, each piece has to connect to the next one in the right order. If the sequence is wrong or if one layer is skipped, the assembly may still look finished from the outside, but the protective system behind it is already compromised. And this is where the real engineering trade-offs tend to appear. Not in the visible features of the house, but in the invisible details, how carefully the weather barrier was integrated with the windows, whether the insulation actually fills the cavity it was supposed to protect, whether the air barrier was sealed around penetrations instead of left open behind tubs, ducts, or wiring. On paper, the house may still meet the required specifications. The insulation has an official R value. The HVAC system meets the capacity requirement. The exterior materials look clean and complete. But the performance of a house doesn't live on paper, it lives in the installation. And when installation quality slips even a little, the first system that usually starts telling the truth about the building isn't the HVAC system or the electrical panel. It's the one element that never stops testing the structure. Water. The hidden water path. Water is the only inspector that shows up for free. Every storm, every season, every year you live in the house. And unlike a scheduled inspection, it doesn't just look at the surface, it tests the entire building. When building scientists talk about water damage, they usually start with one important distinction. There's moisture in the air which moves slowly and can often be managed by ventilation and insulation. And then there's bulk water, actual rainwater moving under gravity. Bulk water is the one that destroys houses. A roof collects an enormous amount of rain during a storm. All of that water has to travel somewhere. Gutters and slopes are supposed to guide it away safely, but along the way, the flow passes through critical transitions in the building. Roof edges, wall intersections, window openings, balcony connections. Those are the locations where water pressure concentrates and where the protective layers have to work perfectly together. In theory, they do. In practice, those locations are built by several different trades, each installing a different component. Flashing siding, weather barriers, sealants, trim pieces. If the sequence is slightly wrong, if one layer doesn't overlap the next, the way it should water doesn't need a dramatic opening, it just needs a small path. And here's the difficult part for homeowners: those paths can stay invisible for a long time. Modern exterior materials are good at hiding problems. Vinyl siding, fiber cement boards, even brick veneer can allow water to move behind them, while the outside still looks perfectly normal. The wall dries slowly, structural wood absorbs moisture, and over time, that small leak quietly turns into rot. Often the entire process starts with something incredibly simple. One of the most important details at a roof-to-wall intersection is a small piece of metal called kick-out flashing. Its only job is to divert rainwater away from the wall and into the gutter system. Without it, water running down the roof can be directed straight into the siding and the wall assembly behind it. It's a small component. In many cases, it costs less than a dinner out. But if that detail is missing or installed incorrectly, the repair years later can involve opening the wall, removing damaged sheathing, replacing insulation, and rebuilding the exterior finishes. And that's the nature of water problems in houses. They start quietly, they stay hidden for a long time, and by the time they finally reveal themselves, you're usually paying for damage that began years earlier. But water isn't the only system that can slowly work against a house. In modern homes, air movement can do almost the same thing. The pressure house. The easiest way to think about it is this: air behaves a lot like plumbing you can't see. Every time your heating or cooling system turns on, air is pushed through a network of ducts and vents throughout the house. At the same time, bathroom fans, kitchen hoods, wind pressure outside, and temperature differences between floors all create small pressure changes inside the structure. Air always moves from high pressure to low pressure, and when it moves, it looks for the easiest path available. In a perfectly sealed building envelope, that movement would stay mostly inside the ducts and ventilation system where it belongs. But in the real world, small gaps exist everywhere around recessed lights, attic hatches, plumbing penetrations, electrical boxes, and duct connections hidden behind walls or ceilings. Once those gaps exist, the house itself can start acting like a pump. If supply ducts leak into an attic, conditioned air escapes into a space that isn't supposed to be heated or cooled. If return ducts leak, the system can pull dusty, humid attic or crawl space air back into the house. Either way, the pressure balance inside the home changes. That imbalance leads to the kinds of problems many homeowners notice, but struggle to explain: certain rooms that never seem comfortable air, that feels damp in the summer dust that keeps reappearing, no matter how often you clean, and energy bills that seem strangely high for a brand new home. Part of the reason these issues persist is that HVAC systems are often installed to meet capacity requirements, but not always carefully commissioned afterward. Commissioning is the process of measuring airflow, balancing the system, and confirming that the equipment is actually performing the way the design intended. Without that step, the system may technically work, but the house never quite feels right. And when air starts moving moisture through the structure, the next place problems tend to appear isn't inside the walls. It's under the house itself. The grading trap. And when you go looking for the next failure, you don't look at the walls. You look at the ground. Because the foundation isn't a magical barrier separating your home from the earth. It's a system that quietly assumes one thing: water will be kept away from it. In residential construction, there's a very simple rule meant to make that happen. The land around a house should slope away from the foundation, typically about 6 inches over the first 10 feet. That gentle slope is supposed to guide rainwater away from the structure before it has a chance to soak the soil around the footing. On paper, that sounds straightforward. In reality, that slope is one of the easiest details for a property to lose over time. Backfill soil settles. Landscaping crews reshape the yard. Walkways, patios, and driveways are installed months after the structure is finished. What started as a proper drainage slope can quietly flatten out, or worse, tilt slightly back toward the house. When that happens, rainwater begins to collect where it was never supposed to stay, right against the foundation. Roof runoff can make the problem worse. Downspouts that discharge too close to the wall dump large volumes of water into the same soil zone again and again. Over time, that soil becomes saturated, and the ground supporting the structure stops behaving consistently. Some soils shrink when they dry and expand when they absorb water. If one part of the foundation sits over wetter soil than another, the structure doesn't move evenly. One corner lifts slightly, another settles, and the stress begins to show up inside the house. At first, the symptoms look harmless. A hairline crack in drywall, a door that rubs slightly in the frame, a tile that pops loose on the floor. But those small clues are often the building responding to slow movement underneath it. And here's the frustrating part for homeowners. Fixing the cosmetic damage rarely solves the real problem. If the water around the foundation isn't redirected through proper grading drainage or downspout extensions, the same cracks tend to return. That's why foundation issues often start as something much simpler, a drainage problem at the edge of the property. By the time the structure begins to reveal it, the ground has already been telling the story for a while. How to buy a new home. So once you understand how houses quietly fail water in the walls, air moving through the structure, and moisture collecting around the foundation, the next step becomes simple. You stop guessing, you start auditing. And the easiest way to do that is to treat a new house the way an engineer would treat a machine. You create a file for it. Imagine a simple folder labeled Home Audit Packet. Inside it are 4 tabs: tests, photos, contracts, and a ledger. If a house is truly new, the documentation around it should look just as new. The first tab is tests. Because if something can't be measured, it's really just a promise. A properly documented new home should be able to show proof of basic performance tests. That includes a blower door test that measures how much air leaks through the structure, a duct leakage test that confirms conditioned air isn't escaping into attics or crawl spaces, and HVAC commissioning records that show airflow and pressure were actually measured when the system was installed. Programs like Energy Star even publish commissioning checklists, specifically for this reason, to confirm that the system works the way it was designed, not just that it turns on. The second tab is photos, because photos beat memory every time. Before drywall closes the walls, the critical details of the house should exist in a visual record. Roof-to-wall intersections, window flashing, attic penetrations, plumbing shutoffs, cleanouts. Anything that will eventually disappear behind finishes should be documented while it's still visible. The third tab is contracts and warranty instructions. Warranties are real, but they are also procedural. What matters is knowing exactly where claims are submitted, what documentation is required, and how quickly problems are supposed to be addressed. And the last tab is the most important one, the ledger. This is where you treat the house like equipment. Every issue gets logged with the date, location photos, and what was done to resolve it. Over time, that ledger becomes a history of the building. Because a home isn't finished when it's sold, it has a life cycle. Most major systems inside a house, water heaters, HVAC equipment appliances, operate on a roughly 10 to 15-year rhythm before they need replacement. In other words, new doesn't mean the story is over. It means the clock has just started. And the homeowners who understand that, who keep records, who watch the systems, who think like auditors instead of shoppers, are usually the ones whose houses stay quiet, dry, and predictable for the longest time. A new home can look perfect on closing day. Fresh paint, clean floors, everything shining. But as you've seen today, the real story of a house isn't in the showroom moment. It's in the systems behind the walls. Water, air, and the ground underneath are always testing the structure. The good news is that once you understand those patterns, you're no longer buying blindly. You're evaluating a machine. If this kind of calm, practical audit helped you see houses a little differently, consider subscribing. We'll keep breaking down the hidden engineering inside everyday machines and homes.